All right, so back to example number 2. We want to find the rate of change between these 2 points, point 1, point 2. So this is our x1 and our y1 and our x2 and our y2. Let's think about what these would look like on a graph. All right, if we had 6, 19, I'm going to kind of make this smaller. So let's say 6 was here and 19 was here. And then relative to that, if this was 6, then 12's out here. And if this was 19, then 24 is up here. So you see it looks like this. So this is also a constant increase, just like the last one. Doesn't look as severe, so the number shouldn't be as big. This one was a number slightly more than 1. So I suspect this might be closer to 1 or less than 1. So let's go ahead and use our formula and find the actual rate of change. So y2 minus y1, x2 minus x1. Again, it doesn't matter which one you call, the 1 and the 2. You just need to be consistent. All right, so subtracting my y values, I've got 24 as y2, and I'm going to minus the other y value of 19. And my x values is 12 minus 6. Okay, so I'm going to get a positive 5 on top. I'm going to get a positive 6 on the bottom. If you were to get something that can be simplified, then you should simplify it, but 5, 6 is fully simplified. And that's a good rate of change. Notice this number is a little less than 1. So that's why this line is not going up quite as steep as this one. So the steepness is represented by how big this number is. So since this is a little less than 1, all right, this rate of change is not as steep on the graph. Last one, example number 3. Let's calculate the rate of change between this and this. Now, if you notice, the y values have not changed. So negative 7, 5. I went negative 7 to the left, up 5. It's up here somewhere. And then if I went positive 7 over here somewhere, but then up the same amount because it's 5. Okay, they both went up 5. That's going to be a line that goes straight across. So my drawing's not perfect, but this is going straight across. It's not going up. It's not going down. So there's no change here. So we can predict what's going to happen with our numbers. They should be 0. All right, so let's see what happens. So we have y2 minus y1, x2 minus x1. So when we subtract our y values, it's 5 minus 5. And you can see what's going to happen there. And then on the bottom, you may think it's going to be 0, but just hold on because it's x2, which if I'm going to call this number 1 and this number 2, x2 is 7 minus the other one, negative 7. So when I do minus and negative, it actually goes plus plus. So that's 14. But the top is 0. And 0 divided by anything is just 0. So there is no change. And just a reminder, we didn't do one here, but if we had points that were going down, it would still look very similar to these. We would just end up with either the top or the bottom negative. It doesn't matter which one. If both of them are negative, like I talked about up here, they would cancel and actually be positive. So if you get a negative on top and negative on the bottom, cancel them out. It's actually a positive rate of change. But if one of them's negative, and it doesn't matter which one, the top one or the bottom one, if just one of them's negative, that makes the whole value negative. You don't have to put it on the bottom or on the top. You can put it out front at that point. The whole rate of change is negative, and that would represent a constant decrease.